Okay, welcome back everyone. Let's just get straight into the recap of where we got to for the last session. So what we did in where we got to in the last session was we started putting down the send message RPC method, which is the one of the methods that the A2A protocol provides in order to send requests and to interact with a particular agent. So we set this up and then started linking up to an actual LLM. In our case, we were using the Google Gen AI SDK and using the Gemini Flash model as the brain slash reasoning engine LLM in this agent that we're building. And we allowed that agent to process the incoming request from the user, which was asking around what the weather conditions were for the particular day in the given city, and then taking the response from the LLM and returning it as an A2A task. So the A2A task being the container or unit for work to be done by an A2A agent. And so we just have this very lightweight, very simple, I need a weather report. Okay, when I'm able to deliver you that weather report, my task is complete. And so that's where we got to, and when we tested that, and we saw that the A2A agent actually provided an answer as to what the weather was. Now, this answer is definitely not correct, and because the LLM has no way to actually receive today's current weather information. These LLMs are trained up to some date with a knowledge cut off, and so this answer is completely hallucinated. It doesn't actually have the ability to answer that question properly. So then that begs the question, well, how does one actually deal with that properly? How do you provide the ability of these agents to reach out and to get that type of information, like what the current weather is today? And for that, we're going to start diving into the tool calling side of things, and start looking at what it looks like to register tools and have an agent actually use tools. So yeah, let's just get straight into that. So if we look at the generate content config, which is just configuring how the how the LLM is set up, there's two key. Let's actually just look at them quickly. There's two key properties here that are of relevance. So I'm just going to get rid of the rest again. So there's these tools and this tool config. So what does it mean to actually register a tool on LLM? So to register a tool in the LLM basically provides the ability for the LLM to take a particular action. So tools have names, and then they also have a schema. So you know by the name what action the particular tool is to be taken at any given point in time. And then also you provide a schema with that tool definition. And that schema, you can think of it almost as mirroring the inputs for what it would look like to run a particular parameters of a function or the body of an API, for example. So you would tailor that tool definition schema to the inputs you require in order to take that particular action. And so yeah, we're gonna look at that now. So I think the easiest is just to actually start putting that down. So we'll just quickly we're going to look at function declarations. So just start getting into our first one here. So this function declaration is essentially the specification for our tool. So let's just actually start the server quickly. So this function declaration is the definition for the tool that we want to register on the LLM. So we need to give it a name. So this allows the LLM to identify the action to be taken. So I like to sort of think of it as the action. So given that we're wanting to retrieve weather reporting information, it makes sense that one of the actions that our LLM can do is to reach out to some or other API or service and take the action of retrieving that. So let's call the action get weather report. And then also quite importantly, it allows us to provide a description for this tool. So the LLM will have all of these function declarations available to it somewhere in its context window, and therefore when it's busy reasoning around the given task, it has the ability to reference this description and understand, okay, like given the scenario, what I'm currently busy with, is this tool a good fit for what I'm doing based on its reasoning on natural language description. So this description is quite important. We're just going to keep it quite simple. So it retrieves the current weather report for a given city. So now the LM will know what this tool is all about and what it can be used for. So the next missing piece is like, okay, but what does the LM, like what inputs are actually required in order to retrieve this information? Well, given that we want to make this agent, we want it to be quite general purpose, it wouldn't be too helpful if we hard-coded that this agent could only fetch information for a given city like New York or London. We'd want the user to be able to dynamically specify, I'm wanting weather information for city X, city Y. So it makes sense that that what city we're after is actually a parameter in this tool invocation process. And so in order to do that, we actually register a parameter or set of properties for this tool definition, providing it a schema for what that looks like. And so this just follows standard JSON Open API spec. So the spec that we're providing is just a simple object, and it has some properties which are just a map of these different properties that we care about, and those themselves are these schema objects. And then it also has required fields, so just a list of what are the properties that are sort of non-negotiable and have to be required, or are required in order to call this. There might be cases where there are some parameters which are optional. So in this case, we know that we just need a single parameter, and that's just the city. And so we can keep this quite simple. The type, so because the city is something like New York, London, whatever the case is, so we can just keep that as a type string. And then what's also quite useful is we can give a property level description. So the LM doesn't just understand what the tool as a whole is used for, but it actually understands the intent behind this particular property. So the LM can reason about your incoming request and be able to translate that into this object or into this property. For example, what is the weather today in London? We'd expect the LM to be able to extract city as being London. So that's the idea. So it's useful for us to provide a description for this so that the LM knows what the intention behind this property is. So it's just of the name of the city for which to retrieve the weather information. So now the LM has a tool, and then we just want to make sure that, given that we want to populate or retrieve weather information for a given city, we want to ensure that the LM knows that the city parameter is required, and so it must populate that for us. Right. Then just a note quickly on the tool config. So there's a couple of variations for how you can configure the use, sort of tool use with these LMs. The mode is, so there's two sort of properties that are of relevance. There's the mode, and then there's allowed function names. So there's various modes you can run function and tool calling in. You can run it in sort of the auto mode, which basically allows the LM to decide at any given point in time whether a function call is actually relevant or not, and if not, it will just defer back to just responding in natural language. In some cases, you might explicitly want to force that it is always a function call, and therefore you could sort of set the mode to this mode any, which implies that there will always be a function call involved in as a response by the LM, or rather the LM will exclusively respond with function calls. And so just going to make use of that for now. There's a couple of other advantages to that which I'll explain along the way. But so at the moment we're going to configure to mode any, and so we know that there will definitely be a function call response. And now now that we've registered this this function declaration, we can now's maybe a good time to actually test and see, okay, now that the LLM has this function definition available and we've told it it has to respond with a function call, how is it going to actually respond differently based on how it was relative to before we registered this function. So if we just run the server quickly, and then we send through our request and just breakpoint just after the LLM has responded. So if we just inspect the response of the LLM a little bit, so we can go to the candidates, content parts, and we can see that in the response signature in the parts there's a function call there. So we can see that the model has taken this input, what is the weather today in London, and has inferred that the particular function call, we're forcing function calls, so it still has to make a decision as to which function call to make. In this case, there's only one. But yeah, it's inferred that the get weather report function call is appropriate given the incoming request and intent. And it's understood that the city for which this weather report is required is London. So we sort of confident and comfortable now that the fact that this is actually working as expected. So the LLM is able to make that function call. But what the LLM is not going to do now at this point is actually be responsible for executing that function call. It's just told you, right, this is the function call that you need to make, and these are the parameters that you need to execute it with, but I'm handing that over to you, or the sort of the agent runtime application to actually just take care of, and then let me know when you've done that and any response that you received as a result of doing so. So the agent or the LLM's responsibility stops at predicting or surfacing a given action at a given point in time with parameters, and then it's not its responsibility until you've come back and actually provided that response to the LLM. And there's a very specific way that you do that using the SDK. And so we'll just start looking at that now. So given that we now know that our model is responding with function calls, we can actually, it's not necessarily guaranteed that there will always be a single function call in any given response. So there might be multiple. And the Gemini SDK provide this quite useful helper function to be able to say, okay, in the response, tell me what all give me a list of all the function calls that needed to be made, or that the LLM is predicted need to be made. This could be one or two or several. And the reason we can do this, at least for now, confidently, is the fact that we forced function calling to always be active. So we don't need to handle text type responses. We're just handling function call responses. And again, we'll get into a bit of the details why this is quite convenient in a bit. So just iterate through the function calls and invoke each as required. Okay, so given that when we looked at in the debugger a moment ago, we saw that for a function call, the information that's available when the LLM is predicted one is the name and then the arguments, right? So given that we potentially have multiple functions, what we need to check first of all is which function is the model actually predicted that we need to invoke. And so that's just a very simple sort of switch case on this function call name. So we just register a case for each of the different functions. So what did we call this one? We called our get weather report function, and this just means we now execute the logic to go and retrieve a weather report. And then likewise, if there were any other tools we needed to handle for, we would go and register them. But for now, let's just stick to this single weather report function. So what I've done ahead of the time is I've quickly just created this very simple weather API Go server, and it's really just a simple HTTP server with a single endpoint /weather, and all it does is if you invoke it, it's going to give you some mock weather data, and this is effectively just to basically mimic the process of whether this LLM was reaching out to some external service that's sitting behind some API. The fact that this is just a little toy server that will run on localhost, it effectively is the exact same principle. So we've got this weather server. So given, let's just actually get this running. So we're just gonna go run this weather server. So now we've got a weather API running on port 8090, and it's available on our localhost. So just wanted to point that out quickly. And so moving back to the function calling, it's at this point where, given that we've now caught, okay, this is the particular function call that's being requested by the model, we now need to go and actually execute that function calling. And so now whatever logic sits here is completely up to the agent application, or us as the agent designer, to go and implement what needs to happen here, right? And so at this point, given that we want to actually reach out to some external system, this logic is where we would go and hit some external API to try and get some weather report information, and then be able to provide that back to the agent. And in our case, we're just mimicking that process via a very simple locally running weather server. So the first thing we're going to do is just define our a little data struct for our request. So this weather API that we put down is going to obviously take in the city as part of the body of the request to the weather API, and provide that to the API, send this request off, get back a response, i.e. the weather information, and then we can provide that weather information to the LLM in order to understand or know what the weather is. So we just want to quickly just set up our data structures for that. So we've just got this data struct, and then we want to actually populate it. So let's populate some data. So what is the city? So to get what the city actually is, we can just go to the function call .args, right? So we know that the function call arguments contain the city in it. So, and it was a map of those properties that we registered. So the arguments in our function call for our get weather report will match the schema that we provided here. So we know that the key that we can access is the city. So we can just access the city, and because it's of I think it comes back as a sort of any type, we just explicitly cast that to a string. So now we've basically parameterized our request that we're going to post as part of the body to our external weather API, i.e. our locally running weather API, which is on a separate server altogether. So then the next thing we want to do is just marshal that into some JSON, so that we can actually send that data on. So if the error is not equal to null, we just want to return null the error. Okay, so now we've got some JSON data, and then we want to make a HTTP request to the actual server, the weather server. So we're just going to want to make a new request here, it's going to just be a post request, and it's running on localhost, or just give it full HTTP localhost 8090, and it's just got a single weather endpoint, and so we can just provide that. So that's our API that we need to hit, and then we want to just pass in the JSON data as the body that needs to be sent with that API request. And we just want to check for the error for that, return on error. And then we just want to set on the header, just because we're sending some JSON. So content type, application JSON. And then we want to actually just set up our HTTP client to go and send that request. So now finally we can just client.do and execute that request. Just again check for errors. So this is just all standard HTTP Go library stuff. And then finally, so at this point we would have reached out to that external API and received our response. And then we want to actually just start, that response is in if you look at the type, it's just that HTTP response type. And then we want to read in the actual body of the response that we got. So now we've got, and again, just check for errors. A lot of error handling in Go, which makes it really useful to catch any errors. You have to be quite pedantic with it. Right, so now we've got our body in bytes. So if we body string, so if we just cast that to a string, we now actually have, in a string format, we would have the JSON response from that API, which we looked at here. What we expect is just sort of some JSON body data with some mock temperature data, as if we were reaching out to some real API. So that's what would be contained in this body string. And then now that we have this, we actually need to communicate and share this back to the LLM, so that the LLM knows that it's the application has actually gone and invoked a tool call and come back with something that it can use, so that the LLM can continue and see if it now has enough information to actually answer the user's question. So the way to actually send so before we get to that, there's just a bit of cleaning up that we need to do. So we actually, to make this whole thing more agentic, agents, like a very simplified version of an agent, is just an LLM sitting in the middle of a for loop with the ability to reach out and invoke tools. But at the moment, this is really just a LLM call script and then calling some functions. But there's no ability for the agent to call a function and then call a function, get some response, reason about what it's received back, optionally invoke another function, or decide, okay, I've got everything I need, let me respond to the user. There's none of that yet, so our application isn't actually agentic yet. So the first step into making that more agentic is to actually just put this everything we've got up until this point into effectively a while loop, and that's already going to make this start feeling a lot more agentic, because now it has this ability to reason and loop over itself and figure out sort of whether it needs more iterations to make more tool calls, or is it satisfied with information it has. And so the reason, so that was step number one, just to start making this a little bit more agentic. And then the other thing that I just wanted to introduce was to have a content. Yeah, so just put a variable up front capturing these things, or these Gen AI contents, and we'll see why in a second. So let's just create content here. So this is a Gen AI dot content, and we want to pass in this information. So we're setting this up front rather than having it inside the loop, and I'll explain in a second why this is useful. But essentially we want to replace that bit. So we've now sort of upfront set the initial context for the LLM, and then we have set passing in that context over there. So got the initial context, and then we've got the sending that through to LLM. Now the reason we did that is because when we get into this tool from calling world, we actually want to ignore this at the moment. We can't reach this return statement because we're sitting in an infinite for loop at this point. But we'll sort that out. But so at the moment we've got this body string, but we actually need a way to add that to the context of the model, so of the LM, so that in the next iteration of the loop it has that response in its context, in its available context. So what we actually need to do is append this result to the contents, so that when we loop again around, we'll again end up looping back to the beginning again, and at this point this contents would have had additional data appended to it, and so the next time that the agent loop runs, those contents have grown with, including both now the original message that came in, as well as now this function response that the LLM has received. And so the way that we do that is, so we want to contents equals append. So we are wanting to, at this point, append the contents or the response that we received back to the LLM for the next loop. So the way that we do this is, so again, we've got these, just get rid of this, we don't need the role here. So any input that we specify to the Gemini SDK is in the form of a part, and if we just look at the parts, there's these different types again, and you'll see there's one specific one that's of interest here, and that's called a function response. So the function response type is basically the part representing a feedback of response after having invoked a function call. So Gemini can understand, okay, like I've asked you to invoke a call, you've done that for me, so please provide me with the response that you received by executing whatever piece of logic or reaching out to an API, whatever that looked like. Just give me back the response that I can do something with it now, right? So if we just look at what that function response looks like, you can ignore most of these. The ID isn't actually necessary at all. So the name. So because we are actually in the get weather report function execution, we tell it, okay, well, the information, the function response that I'm providing to you now is for the for the weather report tool that you asked me to execute. So one-to-one mapping between, we're currently busy with the weather report, I'm telling you I've done that, and I'm giving you back information from that get weather report function tool that you asked me to invoke for you. And then the response is the map containing whatever was received back from the API. So we can keep this quite simple. we know we're getting back this string which contains a body, sort of a JSON body of some weather information. So we're just going to keep this super simple and pass in the body string. So now at this point, what we've done is we have passed back the API response to the LLM. So now at this point, the LLM has in its contents the actual response from the function call, and it will now reach the end of this loop, assuming there are no more function calls to invoke here now, because we've only handled for this one. So assuming there's no more other function calls to handle for, it would reach the end of this iteration, reach the end of the for loop, and then be right at the top here again, and then invoke again with a fresh updated set of contents. Now, as it currently stands, we are forcing function calling, and we have only one function available, and so this for loop or while loop that the agent is operating in is effectively infinite. There's no way for it to actually break out and say, okay, like I've now got information that I need, and so I'm satisfied to actually get back to the user. And so given that we don't have that, we need to now give them the agent sort of an exit action, if you want to think about it like that. So getting back to this mode any, the reason that I quite like doing it this way is because I like to explicitly model all the actions that I want the LLM, my agent, to be able to take, and forcing that function calling is always present, and explicitly registering all the actions is a nice way to control that. So being quite explicit rather than implicit, i.e. assuming the absence of a function call implies getting back to a user or being done. I rather just like to make it quite explicit. So that being said, the way to make that quite explicit is to register a tool dedicated to basically giving control or responding back to a user. So we can just create a very simple function call. Let's call it send message, and the description we give to this is use this to respond and or communicate with the user. So now this is another action that the LLM can take, and so it now has the ability not just to retrieve weather information, but also the ability to engage back with the user. So in this case, we're just going to the item or the property that we want this this particular tool to have is just a message. What is the message to the user? And so this is a message or instruction to the user. So now we've registered and the message is we're going to have that as required. So now we know that the agent has two possible function calls available to itself, this one to retrieve weather and this one to engage with the user. So we actually now need to give or handle the case where it's invoking that send user function. So if we want to register a new case on the switch statement, and so we want to register the case send message. Okay, right, so now we need the task to be done here is to implement this method. Now, to keep things simple for now, we are going to assume that if the agent invokes the send message, that basically means that the agent has considered the task to be complete. And so this send message is going to be our sort of terminal / breakout point for our agent. So if the agent invokes this, we want to consider whatever task it's busy with as finished, and so actually return something to the user. So this is where this guy comes into play again. So we're just going to remove that from there, which could never have been reached. And we're going to place that there. And now that output from the model is no longer the response, it's now actually the message that we have modeled as a property of this send message tool. So instead of having now the natural language response, i.e. .text from the LM, which we had before, so if I just put it back, the way we previously got the response, text-based response, was from looking at getting the .text part, but now we're actually using the message property of our tool call as the response back to the user, and this is type string. So then this message now instead becomes our function call .args, and then we reference the message key, and it is simply a string. So that's effectively the output response for our completed task. And otherwise everything's exactly the same. It's still the same task ID, like status and everything the same. The only thing that changed now was the fact that where this output comes from. And the fact that we are now returning here means we will break out of, this is sort of a forced exit out the loop, and we're fine with that because we made the assumption that invoking this tool is the sort of the exit strategy, the way that the agent exits the loop and hands control back over to the user, so that's okay. And then this send message RPC method will end. And so we pretty much there now to a basic working version, assuming we haven't made any typos or mistakes somewhere. But what we expect to happen now is the request will come in from the user. We populate the initial context with the request of the user. The LLM will register the different function declarations on the LLM. The LLM will hopefully understand our intent that what we want is the weather today from London. We would then expect it to invoke this get weather tool, which will then reach out to this local API, which we still running on this local server. It will receive a response from the server, and we pass that response back to Gemini. And then because there's no exit condition here, it's simply going to just reloop to the top again, and we've now appended that context to the overall context, and the next time around we run, the contents would have been updated. Gemini will run through again that process, hopefully now realizing that I've actually now got the weather information I need, and so the appropriate action to take would be to send a message to the user, and the LLM will take responsibility for communicating the message to that user. So I think we're pretty much ready to run. Let's actually just for visibility's sake, let's say invoking the get weather port tool, and we'll likewise do the same thing here, so invoking the send message tool, and that would hopefully just give us a bit of visibility when we actually running this. And so if we run our agent again now, so we run our server, hopefully we haven't made any mistakes. So that's running. Right, so I think we're ready to run. So let's see if we get a response as we expect. So we see the agent has invoked the weather report tool and now invoked the send message tool. And now if we look here at our response, the weather in London is 20 degrees Celsius with 30 degrees humidity, and it's no coincidence that it's received 20 degrees and 30 degrees, 20 degrees Celsius and 30 degrees humidity, because if you look at our little weather API app that we have running, let's bring that into the main view again. If you just look into that, we set it as 20 degrees, 30 degrees. It's obviously hard coded, but if this were integrating with a real world system, that would obviously give you back live, up to date information. And yeah, the beauty about this is if we wanted to really hook this up to a real API, a real world API, all we need to do is, put the endpoint for that API. If it's some paid for service, we'd have an API key, whatever the case may be, populate the body of that API appropriately based on whatever the requirements are for that API. Here we're just assuming it, just the city is sufficient, and then we've effectively provided the agent with an ability to reach outward to external services, bring in the context it needs, and then sort of reason and synthesize that in order to generate a response and provide the user with some weather report information. And so that's function calling, tool calling in a nutshell, and how one gives LLMs the ability to take action or reach out to external systems. Hopefully that was helpful, and we'll see in the next session where we'll just continue to expand on our agent and continue to explore the A2A protocol. See you next time. Thanks for watching.